Hello everyone and welcome back to my channel. This is the A+ Tutor. Today we're going over graphing tangent functions. Our tangent function is just f of x equals tan x. Here's what that graph looks like across multiple periods. The graph for tangent looks very different than our sine and cosine waves. Our tangent graph is an odd function, so it is going to increase on the right side of our graph and decrease on the left side of our graph. And we are bound by two asymptotes, as you see here, for each graph. Remember, tangent is just sine over cosine. So finding our values for our points on our graph, our standard tangent graph here, we can see how sine and cosine play a role. The period of one tangent graph is pi, unlike for sine and cosine, which are 2 pi. Here's what our table of values looks like. So our values for our x in our tangent function are negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. One wave of our tangent graph spans pi units, which is our period, and goes from negative pi over 2 to pi over 2. Now we can use our definition of tangent, which is sine over cosine, to find what our y values are at each of these points. So let's start with negative pi over 2. The tangent of negative pi over 2 is sine negative pi over 2 over cosine negative pi over 2, which is negative 1 over 0, and that's undefined. Because that's undefined at negative pi over 2, we have a vertical asymptote. Anywhere our tangent function is undefined, we have a vertical asymptote. Then, tangent at negative pi over 4 is sine at negative pi over 4 divided by cosine at negative pi over 4, which is negative 1 over 1, and that's negative 1. Tangent at 0 is sine 0 over cosine 0, which is 0 over 1, and that's 0. Tangent at pi over 4 is sine pi over 4 over cosine pi over 4, which is 1 over 1. That's equal to 1. And lastly, tangent of pi over 2, similar to negative pi over 2, is going to be undefined, which means we have another asymptote there. Now let's look at what some transformations may look like in that standard form of our tangent function. So we have f of x equals a tan bx minus c plus d. To find our asymptotes of our tangent function, we let our bx minus c equal to pi over 2 and negative pi over 2, and then we solve for x. We use pi over 2 and negative pi over 2 because these are the asymptotes of our parent function, f of x equals tangent x. So this tells us where our transformed asymptotes will be on our tangent graph. Next, our amplitude. Our amplitude is the absolute value of a. Then our period. Our period is going to be pi over the absolute value of b. Here, we're using pi because that's the period of tangent. Then to find our intervals for our x values, we'll take our period and divide that by 4. Last, our vertical shift is going to be our d value. That tells us how many units up or down we are shifting our tangent graph. The domain and range for tangent is a little bit different than what it was for sine and cosine. For our domain of tangent, x will be equal to all values except for where our asymptotes are. Now, our tangent graph is cyclical, which means it does repeat over our coordinate grid. So that means we have to account for all places where this might be true. This means our domain is going to be x is not equal to one of our asymptotes plus or minus our period. So this way, we can account for all places where we have an asymptote and all places that we do not have a value for our tangent because it is undefined. Another way you can find the domain is taking your bx minus c, setting that not equal to pi over 2 plus or minus n times your period. We use n so that we can account for all times where this is true, and n is just going to represent integers. Our range, again, different from our sine and cosine graph, our range is negative infinity to infinity. Going up and down, our tangent will have all possible values, but from left and right, we do have some places where the tangent of that value does not exist. Let's look at these transformations in action. Let's take the example, y equals 3 tan x plus pi over 2 minus 2. Our standard form is f of x equals a tan bx minus c plus d. To find our asymptotes, we take bx minus c and set that equal to positive pi over 2 and negative pi over 2. So x plus pi over 2 equals pi over 2, and x plus pi over 2 equals negative pi over 2. Let's solve for x in both of these, and we get x equals 0 and x equals negative pi. These are the two places where we have an asymptote on our tangent graph. These are not the only places there is an asymptote, but these are going to be the two that we will show on our graph. The amplitude is the absolute value of a, which is the absolute value of 3, and that's 3. Our period is pi over the absolute value of b, which is pi over the absolute value of 1, and that's equal to pi. So to find our intervals, we will divide our period by 4, and we get our intervals are pi over 4. Last, the vertical shift is d equals negative 2. Looking at our parent function, y equals tan x, here's our table of values. Our x values are negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. And our y values are asymptote, negative 1, 0, 1, and another asymptote. So let's find our table of values for our transformed function. Our x is going to start at our leftmost asymptote, which in this case is negative pi. So our first x value will be negative pi. Then we'll use our intervals to find our next x value. Our interval is pi over 4, so we will add pi over 4 to each x value. Negative pi plus pi over 4 is negative 3 pi over 4, negative pi over 2, negative pi over 4, and then we end at 0, which is the second asymptote we found. For our y values, our first and last values will be asymptotes. We saw this by solving for those asymptotes. Then, to find our middle 3 y values, we can use our parent function. All we need to do is take our parent value, in this, for example, negative 1, multiply that by our amplitude, and add or subtract our vertical shift. So we have negative 1 times 3 minus 2, which is negative 3 minus 2, and that's negative 5. 0 times 3 minus 2 is 0 minus 2, or negative 2. And 1 times 3 minus 2 is 3 minus 2, and that is equal to 1. Here's what that looks like on our graph. For the parent function, our domain is x does not equal pi over 2 plus or minus n pi. So again, thinking about our domain of our parent function, it's going to be one of our asymptotes, for example, pi over 2, plus or minus n times our period, and the period of our parent function is pi. The range for both our parent and transformed function will be negative infinity to infinity. So the domain for our transformed function is our x does not equal our asymptote, or 0, plus or minus n times pi, because our period is pi. So we can just say x does not equal positive or negative n pi. This is important because if we were to draw another wave of our tangent graph, our next asymptote would be at positive pi if we move to the right, or negative 2 pi if we move to the left, and then we could draw another wave within those two asymptotes. And our range, just like our parent function, is negative infinity to infinity. Let's look at some examples of transformed tangent functions. Y equals 2 tan 1/2 x minus 3. Our standard form is y equals a tan bx minus c plus d. We start with our asymptotes. To find our asymptotes, set bx minus c equal to positive and negative pi over 2. So 1/2 x equals pi over 2, and 1/2 x equals negative pi over 2. Solving for x gives us pi and negative pi, and these are our asymptotes. Our amplitude is the absolute value of a, which is the absolute value of 2, and that's equal to 2. Our period is pi over the absolute value of b, which is pi over the absolute value of 1/2. Pi over 1/2 is equal to 2 pi. So our period for this tangent function is 2 pi. Then to find our intervals, we'll divide our period by 4. So 2 pi divided by 4 is pi over 2, which means our intervals for our x values are pi over 2. Lastly, our vertical shift is d equals negative 3. Here's our table of values and graph for our parent function. Let's look at what our transformations look like for a transformed function, starting with our table of values. So, our first x value will be our leftmost asymptote, which is negative pi. Then we're going to add pi over 2 to find our next x values. We got pi over 2 by dividing our period by 4. So negative pi plus pi over 2 is negative pi over 2, plus pi over 2 is 0, pi over 2, and pi. Again, we have asymptotes at negative pi and pi, so we know what those values are. Now let's find our next 3 points that we have on our graph. So we'll take our first value of our parent function, which is negative 1, multiply that by our amplitude, and then add or subtract our vertical shift. So we have negative 1 times 2 minus 3, which is negative 2 minus 3, and that's negative 5. 0 times 2 minus 3 is negative 3, and 1 times 2 minus 3 is negative 1. So now we can graph our asymptotes, those 3 points, and show our tangent function. Our domain of our parent function is x does not equal pi over 2 plus or minus n pi, and our range is negative infinity to infinity. The domain for a transformed function is going to be, keeping in mind, our domain is an asymptote plus or minus n times our period. So our domain is x does not equal pi plus or minus 2n pi. Since our period is 2 pi, we have to make sure we include that. If we just wrote n pi, just like our parent function, then that means there could be an asymptote at x equals 0 or x equals 2 pi, which, looking at our graph, we know is not true because we have the value 0 on our graph. That is not an asymptote. So whenever we're writing our domain, we have to make sure that we include the period times n. And our range is -infinity to infinity. Let's take another example. We have y equals tan x minus 3 pi over 4 plus 1. And standard form is y equals a tan bx minus c plus d. To find our asymptotes, set bx minus c equal to positive and negative pi over 2. So we have x minus 3 pi over 4 equals pi over 2, and x minus 3 pi over 4 equals negative pi over 2. We'll add 3 pi over 4 to both sides. We can rewrite pi over 2 as 2 pi over 4. So when you add 3 pi over 4, you get 5 pi over 4. And when you add 3 pi over 4 to negative 2 pi over 4, you get pi over 4. So those are our two asymptotes of this function. Our amplitude is going to be the absolute value of 1, which is 1. Our period is pi over the absolute value of 1, which is pi. And our intervals are a period divided by 4, which is pi over 4. Last, our vertical shift is d equals 1. Here's our table of values and graph for our parent function y equals tan x. For our transformed function, let's find our table of values. Our x will start at our leftmost asymptote, which is pi over 4, and then we'll add pi over 4 to find our next x value. So we get pi over 2, 3 pi over 4, pi, and 5 pi over 4. We have two asymptotes at pi over 4 and 5 pi over 4. So let's find our other values. We'll take -1, multiply by our amplitude, which is 1, and add our vertical shift, which is also 1. So -1 times 1 plus 1 is 0. 0 times 1 plus 1 is 1. And 1 times 1 plus 1 is 2. So now, let's graph our transformed function. Our domain for our parent function is x does not equal pi over 2 plus or minus n pi, and our range is -infinity to infinity. Our domain for our transformed function, x does not equal our asymptote, pi over 4, plus or minus n pi, and our range is -infinity to infinity. Here's our next example. Y equals -2 tan 3x plus pi. Standard form, y equals a tan bx minus c plus d. This negative in front just means we have a reflection over the x-axis. When we find our table of values for this transformed graph, you'll see how the reflection affects your table of values, and we'll see it in the graph as well. Our asymptotes are bx minus c equals plus or minus pi over 2. So 3x plus pi equals pi over 2, and 3x plus pi equals negative pi over 2. Solving those gives us x equals negative pi over 6 and x equals negative pi over 2. Our amplitude is equal to the absolute value of negative 2, which is 2. Our period is pi over our b term, which is pi over 3. So our intervals are our period divided by 4, which is pi over 3 divided by 4, and that's pi over 12. Our vertical shift is d equals 0. Since we don't see anything on the end of our transformed function, we know that that means d is equal to 0. Here's the table of values and graph for our parent function, y equals tangent x. Let's find our table of values for our transformed function. Our leftmost asymptote is negative pi over 2, and our intervals are pi over 12. So we'll add pi over 12 to each x value. That gives us negative pi over 2, negative 5 pi over 12, negative pi over 3, negative 3 pi over 12, and negative pi over 6. Negative pi over 2 and pi over 6 are asymptotes on our graph, so we'll list those as such. And let's solve for our next three values. Negative 1 times negative 2 is 2, 0 times negative 2 is 0, and 1 times negative 2 is negative 2. So now we can actually graph this transformed function. Again, we see that reflection because the transformed function has that mirror image over the x-axis of our parent function. Our domain of our parent function is x does not equal pi over 2 plus or minus n pi, and the range is negative infinity to infinity. The domain of our transformed function is x does not equal negative pi over 6 plus or minus pi over 3. Our asymptote is negative pi over 6, and our period is pi over 3. So we include both of those in our domain. And the range is negative infinity to infinity. Next, we have y equals 1/2 tan 2x plus 1. Standard form, y equals a tan bx minus c plus d. Let's find our asymptotes. So 2x is equal to pi over 2 and negative pi over 2. Dividing 2 on both sides means x is equal to pi over 4 and negative pi over 4. Those are our asymptotes for our function. The amplitude is the absolute value of 1/2, which is equal to 1/2. Our period is pi over 2, and the intervals are pi over 2 divided by 4, which is pi over 8. Last, our vertical shift is d equals 1. Here's our parent function. Now, let's find our table of values for our transformed function. Our x values will start at negative pi over 4, and our intervals are pi over 8, so we'll add pi over 8 to each x value, giving us negative pi over 4, negative pi over 8, 0, pi over 8, and pi over 4. Now let's find our y values. Our first and last y value is our asymptote, and then we'll use our parent function to find the next three. So negative 1 times 1/2 plus 1 is equal to 1/2. 0 times 1/2 plus 1 is equal to 1. And 1 times 1/2 plus 1 is equal to 3/2. Now that we have our table of values, let's graph our transformed function. Our domain for our parent function is x does not equal pi over 2 plus n pi, and our range is negative infinity to infinity. For a transformed function, our domain is x is not equal to pi over 4 plus n pi over 2, our asymptote and our period, and our range is equal to negative infinity to infinity. Here's our next example. Y equals negative tan x plus pi minus 3. That negative out in front means we have a reflection over our x-axis for this graph. Let's find our asymptotes. So x plus pi equals pi over 2, and x plus pi equals negative pi over 2. This means we have an asymptote at x equals negative pi over 2 and x equals negative 3 pi over 2. Our amplitude is the absolute value of negative 1, which is just 1. And our period is pi over 1, which is just pi. This means our intervals for our x values is pi over 4. Last, our vertical shift is d equals negative 3. Here's the graph of our parent function. Now, let's find our table of values and graph our transformed function. Our x will start at negative 3 pi over 2 and have intervals of pi over 4, which means our x values are negative 3 pi over 2, negative 5 pi over 4, negative pi, negative 3 pi over 4, and negative pi over 2. Our y values will have asymptotes starting and ending for our two x values, and then our three values in the middle will be negative 2, negative 3, and negative 4. So now, let's graph this transformed function. Our domain and range of our parent function are just like what we've seen before. The domain is x is not equal to pi over 2 plus or minus n pi, and the range is negative infinity to infinity. For our transformed function, our domain is x is not equal to negative pi over 2 plus n pi, our asymptote, and our n times our period, and our range is negative infinity to infinity. Let's take one more example. Y equals 4 tan x minus pi over 4 minus 1. To find our asymptotes, we'll set x minus pi over 4 equal to pi over 2 and negative pi over 2. So our two asymptotes are x equals 3 pi over 4 and x equals negative pi over 4. Our amplitude is the absolute value of 4, which is 4. And our period is pi over the absolute value of 1, which is pi. This means our intervals will be our period divided by 4, which is pi over 4. Last, our vertical shift is d equals -1. Here's our parent function. And now let's find our transformed function. So our x values will start and end with our asymptotes, meaning it's going to start with -pi over 4, end with 3 pi over 4. Our intervals are pi over 4, so the x values are -pi over 4, 0, pi over 4, pi over 2, and 3 pi over 4. Our y values, they'll start and end with asymptotes, and our 3 middle values we'll find using our parent function. So our y values are asymptote, -5, -1, 3, and asymptote. Here's what this graph looks like. The domain of our parent function is x does not equal pi over 2 plus or minus n pi. Range is -infinity to infinity. The domain of our transformed function is x does not equal -pi over 4 plus or minus n pi, and the range is -infinity to infinity. Thank you so much for watching. I hope you enjoyed and I hope you learned something. If you have any questions or suggestions for another video, please let me know in the comments below. You can also find me on Facebook and on Instagram at the A+ Tutor, and those are linked in the description. See you next time!